So today begins the first official day of the review of, well, the most difficult, important, interesting things that we've done this year in Algebra 2. I had asked you all to participate in the discussion. I love that everybody dove in. And here are the results. You can't really see them all, I guess. But if you notice on here, what I did was I organized from Chapter 3 the whole way down to Chapter 8, because we were in the middle of Chapter 9 when we did this, and there was no reason to ask about Chapter 9. And then every time somebody mentioned a topic, I would write down what the section or topic was. And as more people mentioned, I would put tally marks underneath. So to get the number on there was one person, and then tally marks underneath were the additional people. You'll see a couple things. First, you'll see that there's a lot going on in Chapter 5. There were a lot of requests for things in Chapter 5. So we're going to spend probably a week and a half to almost 2 weeks reviewing Chapter 5. It's good stuff. But you'll also notice up here in Chapter 3, there were the 1 plus 10 more. There were 11 of you, almost half the class, asked for help with matrices, or said of the topics we should review, matrices is at the top. So let's go ahead and begin. In me thinking about matrices as well, I have to admit, I don't tend to use matrices in solving systems of equations. If I get to the point where I'm doing a 2x3 system of equations or a 3x4 system of equations, I often try to find a different strategy. But the more I sat and thought about the larger matrices, you see it right here, as I thought about the larger matrix, like a 3x4, I started to think that the matrix maybe is the right strategy to use. So let's check out the basics and let's go ahead and figure this out. So on the upper left-hand corner, I have a typical 3x4 system of equations. It has 3 variables and 3 unknowns, x, y, and z. And our goal, of course, is to figure out what they all are. I'm not teaching it now. I'm saying that everybody recognizes that we can, I don't know if everybody recognizes it, but I bet we all could go ahead and write a matrix based on the system. You got your x column, your y column, your z column, and your number column. I'm not going to re-explain every step. We'll be here all day. We also have 3 rules. We reviewed these rules last time with the 2x3 matrix. You could switch the rows with one another. You can multiply or divide any row by a constant, and you can add and subtract any 2 rows that you want. Okay, so having said that, the ultimate goal, of course, is that we get a diagonal series of 1s, and that would mean that x is this number, y is this number, and z is that number. Done, right? So that's our goal. So with that in mind, weirdly, instead of talking about 3x4 matrices, we're going to go back to 2x3 matrices. And it was a comment that we came upon in class. I don't remember who said it. I don't think it was me. I think it was one of you guys that came up with this idea of solving an inner core problem and then extending that problem outward. So using that idea, I try to really wrap my head around how to do a matrix efficiently. And what I thought of was a 4-step procedure to get a 2x3 matrix into a solution. And the steps are always the same. I have them color-coded, so I'm not going to write all over the screen and make a mess of it, but I am going to do some highlighting here. I'll pick something kind of neutral like a yellow. The first step was to make the first number in the bottom left-hand corner a 0, and then immediately, well, actually, I have it written on here to make this one a 1. And then the third was make this one a 1 and then make this one a 0. And you saw me just hesitate there because the truth is there's a variety of ways to do this. And the order is not, well, the order doesn't have to be what I say it is. For example, in the next example, I might do this. Make this a 0, which I would probably argue is the best first step. Make this one a 1, make this one a 1, make this one a 0. Now, I don't think anybody watching this video is going to be thrown off by that concept because the work is exactly the same, but maybe how we go about doing those 0s and 1s matters a little bit. I think the first and hardest piece on the whole thing is this gray one, and I want to just take a moment to do this because honestly, of the whole thing, I think this is the hardest one. To get that thing to be a 0, I'm going to use 3 steps. I'm going to make up a fraction, I'm going to multiply the fraction, and then I'm going to add. Fraction, multiply, add. Everything else, I'm just going to be using a reciprocal. So that's how I'm going to complete this problem. Now I have an example. I'm not working through each and every example because we're already at 5 minutes and I don't want this thing taken forever. I made up an example here, already written as a matrix. I want to make that first bottom left-hand corner into a 0. So in order to make this into a 0, you might start being familiar with this. I made a fraction out of the 3 and the 5, right? Here's my 3, 5 fraction. I didn't use the negative sign because I wanted an opposite. I added it to the second row, and I put it in the second row spot. Done. Now, some pretty ugly fractions there. We get those sometimes. Now we're going to go ahead and work on making this one. I was trying to stick to that original plan, make this one into a 1. Look, it's just a reciprocal. To get 8/5 into 1, I use 5/8. Okay. Now I'm going to make this one into a 1. I'm going to use a reciprocal. To make 5 into a 1, I use 1/5. It's a reciprocal again. I started to see this idea that the reciprocal was really kicking in. Look, here it is again. Make this into a 0. So I used this guy and the reciprocal of this one. Now, I suppose you could probably argue this was the reciprocal and multiply and add again. And I don't know that I would disagree with that, but I don't know that this is going to be outside of our wheelhouse. Maybe I need to change the purple one into something a little different, but the concept is exactly within the realm of what we've been doing. So with that in mind, by the way, written out like this is not normally how you'd see it. This one concise piece is normally how you'd have it written down. You'd start in the upper left-hand corner, you'd kind of work your way across, you make this long loopy arc to kind of give yourself more space. And on the arrows that you draw, they don't have to be different colors, but on the arrow you draw, you write down what you've done, and then at the end you go ahead and write down your answer. Simple, right? So that's how you solve a 2x3. And I really spend 7 minutes talking about how to solve a 2x3, because if you can do a 2x3, you can do anything. Watch. Now let's imagine that our goal is to solve a 3x4, right? 3 rows by 4 columns. That's what I mean by a 3x4. To solve a 3x4, here's what we're going to do. We're going to try to get this and this to be 0. That's going to be make a fraction, multiply, and add. Make a fraction, multiply, and add. Right? Top left corner. Oops. Top left corner. Use a reciprocal and turn that into the number 1. Now, as soon as you have that, now just solve the 2x3 matrix. Okay? So we did the top left corner. Now we're going to solve the 2x3 matrix, pretty much exactly the same as the example up on top. And now we need 2 more things to be addressed. The last 2 zeros, I need a 0 here, so use a reciprocal. I need a 0 here, use a reciprocal. Or use a reciprocal and add. That's it, right? That's going to be your entire process. When you're done, you'll have a diagonal of 1s. You'll have your answers to the right of that vertical line, and life will be good. So it really is just a matter of, and I'm just going to say it one more time because I'm not doing an example. We'll be here all day. Step 1, make this and this zeros. Step 2, make this one a 1. Step 3, solve the 2x3 matrix. Step 4 and 5, make these zeros. If you do that, you'll get the right answer every time. And then 9 minutes in, if we want to be crazy, let's imagine what you do here. Just think on this just for a moment. I have these in different colors because I want you to understand that the procedure is going to be the same. And we're sure not going to attempt to write all this down, but think about what you would do. You'd use reciprocals in addition to get a 0 here, here, and here. So 0. Here, here, here. Then we'd make this one into a 1. All right? Now, solve the 3x3 matrix. To solve the 3x3 matrix, we get a 0 here and here, right? So these 2 are done. Make this one into a 1. Now, solve the 2x3 matrix. Same theme. Get a 0 here. Turn this into a 1. Now we can finish the problem off. What I had next was make this one a 1, make this one a 0, and the 2x3 matrix is solved. As soon as that's done, now we're going to make this a 0 and make this a 0. Now the 3x4 matrix is done. And now make this, this, and this a 0. Now the 4x5 matrix is done. Look, we could extend this as big as we want, but the concept is the same. Get that first column taken care of. and then work the next bottom chunk. If you have to do it again and again and again, so be it. But this is how you solve matrices.